We all know that black holes are a fascinating area of astrophysics, of which we still know very little about. However, in the past 102 years since Carl Schwarzschild first predicted such an anomaly from Einstein's theory of general relativity, something else has been lurking in the depths, both figuratively and perhaps even physically. Even despite the huge amounts of evidence weighing in favour of the existence of black holes and the very first radio image of one we hope to capture in the near future, something that has always eluded us is the possibility of what could lie beyond one. It appeals to fantasy as much as it does physics to try and understand what lies beyond the all-consuming cosmic abyss, but perhaps the answer could hold the key to how our universe came to exist. With more and more scientists beginning to support the theory that the Big Bang had something to do with a larger black hole from a potentially much larger mother universe, the maths is starting to point to such a theory on more than one level. If time is symmetrical, then the counterpart beyond a black hole could just point to its complete polar opposite, a white hole. White holes test the boundaries between science and science fiction, and we know very little about this theorised anomaly, as it may very well not exist. However, if they do, and we just can't see them, then perhaps the infamous theoretical white hole could be a potential answer to our own universe's formation. In 2010, we picked up what is known as the Christmas Day gamma ray burst, lasting almost half an hour, almost impossibly long for the length we theorised a gamma ray burst to be able to reach. But with these mathematical fantasies in mind, could this have been the birth of a white hole? And if so, could the very Big Bang that created our universe be the outpouring of one? Black holes came from Einstein's theory of general relativity. The theory's calculations allowed for such an anomaly which we couldn't explain. In the century since, however, we have picked up a substantial amount of evidence that black holes exist and are responsible for a number of interstellar phenomena. If you want to learn more about black holes, you should watch my episode on them first, but in short, a black hole is the product of something massive collapsing in on itself to an infinitely small point known as a singularity. By the time the singularity has formed, nothing in the universe can escape from a black hole's gravitational field, not even light, once it has passed the point of no return known as the event horizon. Black holes are truly magnificent and are usually affected by a number of variable factors: their consumption, charges, movement, surroundings, you name it. However, within the mathematics of an all-consuming gravitational well, there is room for a space-time symmetrical opposite. The concept is quite simple. If a black hole is a gravity well in which matter can only be pulled in and cannot escape, and light is collected leaving a black void-like shape, then the opposite should be a gravity well working in the other direction, ejecting matter and allowing nothing to enter it. Connecting the dots between the two has come to coin the popular sci-fi feature that is a wormhole, but the polar opposite of a black hole may lend a lot more credibility to the theory. But in order to understand how that would work and how the opposite of a black hole is possible by science, we first need to understand the concept of an eternal black hole, something that was proposed by Carl Schwarzschild himself. While the opposite of a black hole may be simple to consider, the science is anything but. Okay, so before we go any further, I just want to address how similar this video will be to all the other white hole videos out there. I do try to make my videos as unique as I can, but when it comes to something like this, the science is incredibly specific and very niche, and there's only a certain way I can really go about it, as can all the other channels. I'll link the best white hole video I've ever seen in the description, but yeah, bear with me if this feels somewhat familiar. Due to the very specific nature of the science, there's not really a lot I can do. The eternal black hole theory is a difficult one to grasp and doesn't take into account our universe's circumstances. But when expressed, it makes for pretty interesting reading and illustrates how a white hole could exist. Basically, if a black hole is eternal, in the sense that it always was, always will be, and won't ever be affected by its spin, charge, or anything else, then time that happens inside a black hole, which we know is already warped by its gravitational pull anyway, would not be consistent with the outside universe. This principle is known as the Schwarzschild metric. It states that the events happening within a black hole would obviously be happening eternally. With this principle in mind, the singularity begins to behave very differently. Instead of being an area, it becomes eternal space-time. As a result, the singularity basically becomes eternal in both the time sense and a directional sense. Why is this important? Well, it's what happens with the inverse of this metric that makes things so fascinating. Mathematically speaking, the opposite of this would be a singularity that represents infinite past, and the opposite effects of a black hole. With an infinite past singularity and inversed effects, everything would be flowing outwards, and the event horizon would be an impenetrable barrier to entry as opposed to a point of no return. The singularity has been occurring, and everything is flowing outwards. The eternal black hole theory may explain why, if true, we could never observe one. If light was being pushed, warped and emitted the other way, outwards, at a black hole's gravitational scale, then large white holes should, in theory, be shining brighter than quasars, so why can't we see them? Well, if the eternal black hole theory was the case, light would technically be travelling an infinite distance with endless space-time in the singularity that it now occupies. Hence, light would never cross the event horizon back out to the outside universe. It's mind-bendingly complex, to be sure, so let's quickly summarise this using a diagram. This diagram represents the space from an infinite Minkowski universe. On the x-axis, we see endless direction, infinite expanse in a sense of length. The y-axis represents time, eternity at the top, and the lower y-axis represents the distant past. If the singularity in question is an eternal singularity of infinite space-time, then it occupies this boundary between the two known as light-like infinity. This boundary extends in the opposite direction beyond the event horizon, but into the distant future. If we reverse it, however, using the principle of time symmetry, then another event horizon is created in the opposite direction, expanding into the distant past. We have the opposite effect here. Here, light would be forced out into the outside universe through an event horizon towards the cosmic horizon, the point on the other side which is basically the edge of the visible universe if the midpoint is us from our perspective. This is why, mathematically speaking, an inverted black hole is so feasible. The maths shows that a time-reversed black hole would not only be possible in this scenario, but would actually fit quite well with our current understanding of general relativity. The only issue is that this is entirely theoretical and from an internal perspective. The calculations don't take into account the finite age and environmental factors of our universe. So, despite being quite mathematically rigorous, more research needs to be done to explain how one could occur within our own universe, and this is why the concept of the white hole is incredibly theoretical and why some argue that it actually doesn't exist. So, bringing what we know from the diagram together, what do we know about the white hole? Well, it is a space-time inverted black hole in short. Like any physical object within the universe, we expect it to attract matter, however nothing would be able to pass the event horizon. Light is ejected out from the singularity and should radiate, although we've never seen any evidence of this. But, if true, where would white holes be getting all this matter at the singularity to be ejecting out in the first place? Well, the graph suggests that perhaps a white hole is what lies beyond the singularity of a black hole, and so the two are somehow connected. This is how Einstein proposed the Einstein-Rosen bridge, also known as a wormhole. It is believed with a wormhole that a spinning black hole could create a gateway to another part of our universe, a way of transitioning across space faster than light by warping the universe's dimensions. A white hole seems to be the undiscussed other side, out of which you can only be ejected from. Some believe that white holes and wormholes may actually be a result of very old, large black holes. Black holes have consumed so much matter that they've essentially burst, and the white hole is the drainage elsewhere in the universe. This would be good news, as one theory on our current understanding of black holes suggests that consumed matter may just disappear in violation of all the laws of physics. A white hole would mean that the matter and information is not lost. But could one realistically form in the universe? Well, one law black holes align quite well with is the law of entropy, the second law of thermodynamics that states that all processes proceed in such a way that the availability of the remaining energy decreases. Energy isn't being lost, but instead it's being dispersed by all processes. This means that the universe is unsustainable, and we'd be heading for an eventuality of totally wasted energy in the universe. Entropy always increases, however we believe a drop in entropy, a reverse given the time symmetry reverse of a black hole becomes a white hole, could create the conditions for a white hole to form. This isn't actually impossible to believe either, so long as the totality of entropy continues to increase universally, then dips here and there or pockets of irregularities could occur. Have we ever observed this? Well, in 2010, NASA's Swift telescope picked up a gamma-ray burst from the accretion disk of a black hole that lasted 28 minutes. Gamma-ray bursts, by our understanding, don't last more than a few seconds. Could this be an indication of a white hole forming? Well, some people have been calling it the small bang, a formation of a white hole being likened to the Big Bang. But there may be more grounds to be comparing the two than we realise, as it seems that white holes are piling more evidence on the alternate or interlinking theory to the formation of our universe. Going back to the principle of a wormhole, some scientists predict that a bridge linking two parts of space together would be incredibly unstable. Some theorise that instead of another part of space, a white hole exit from a wormhole would create and act as a gateway to a new universe entirely. This is purely speculative science fiction, but there is something more. If we return to our infinite space diagram, then our two event horizons spring off in the opposite direction and seem to form two new axes. This means that, mathematically, we could complete these axes with a new mirrored twin copy of our universe, parallel next to our own. This representation lends mathematical credibility to the multiverse theory, that a parallel universe could exist next to ours, or potentially multiple do. This leads us to the very real, very plausible theory that the Big Bang was caused by a white hole's formation, and that we are living inside a black hole of another, much larger mother universe, where the singularity now occupies infinite space-time. This, tied in with the very large or old black hole theory, holds that a universe was created by all of the mass of a supermassive black hole exploding and being ejected out into the new universe in the form of a Big Bang, from our perspective. Sounds reaching for sure, but the Big Bang does indeed share a number of similarities to a theorised white hole. For starters, you cannot see any light emitting from the Big Bang with the exception of the CMB, and if they exist, perhaps white holes are invisible due to the space-time singularities within. Everything is being pushed outwards all over the universe from the Big Bang. A paper released in 2012 argues this theory and claims that the Big Bang is a remnant of a white hole formation, the other side of another universe. Does this mean we were created by a black hole? Well, the theory is becoming more likely, or at least likely that a black hole may have had something to do with our universe's creation. Perhaps a black and white hole pairing is the key to our universe's invention. If true, could learning more about white holes hold the key to understanding our creation? It's a mind-blowing theory, but there's something more. There's a theory called the false vacuum theory, which states that our universe is a mere bubble, expanding within a much larger vacuum. When our universe reaches a certain size, it will burst, or pop, and eventually everything will be destroyed. This seems to chime eerily with the white hole theory. We know that black holes eventually die due to Hawking radiation. Perhaps when a black hole dies, its connection is severed with the white hole and the gateway is closed. If matter is not being inputted into one end, then maybe the white hole would die too, and the universe it has created would die or would stop expanding as the feeder has been cut off. Perhaps these theories all link. Perhaps it could be a mixture of these theories, the Big Bang, the wormhole, the white hole, the false vacuum, all of them holding the true key to where we came from and of course where we are headed together. Despite the grim prospect this foreshadows, let's instead think on a slightly lighter note for a second. If white holes are feeders from other universes, then there's no telling how many of the universes could exist, and could exist within our own. Through history we have discovered that there were billions of planets, and then we discovered that there were billions of stars, and then in the 20th century billions of galaxies. Could the 21st century hold the discovery of billions of parallel universes? Imagine the possibilities that would create. It would be very much in line with what I said in my cold spot video. Maybe the cold spot is an indication of another universe, and if so, maybe it is just one of billions. Creation could be endless, with millions of universes and the repeating laws of physics and structures. It seems that the more we discover, especially around these gravitational anomalies, the less we seem to know. One thing is for sure though, gravity is the fundamental force in the universe and it can do some pretty impressive things. Maybe gravity is the key to hundreds of thousands of other universes, interlocked in a web of creation. Or maybe it's just fantasy, a part of maths that has been overhyped by scientists dreaming. Whatever the case, it seems that the biggest black hole out there is the black hole in our knowledge of the universe and what lies beyond. So, do you think white holes exist? Are they a natural phenomenon, a gateway to another universe, or simply just science fiction? I'd love to hear your thoughts in the comments below, so be sure to drop your opinions there. And with that, thank you very much for watching, and don't forget to reach for the stars.